So let's have a look first at natural length scales. Okay, what's the size? What's the size of, say, different marine species? And this is what's included here. Okay, we look at the typical size of bacteria. Okay, so very, very small, less than 0.1 of a millimeter. Okay, phytoplankton, and this is shown here in this diagram. Zooplankton, fish getting up to can be meters long, up to the largest whale. Okay, so that's all included within this range, and it's probably reasonable to compare these scales, or to put them into context with the natural length scales that you have in the environment. Okay, like we have turbulence, which is like convection, yeah, or you can have a smaller turbulence induced by in the surface Ekman layer, for example, and you can have these turbulent elements in the ocean have sizes between 1 centimeters and 100 meters. Okay, so now if you're a little bacteria and you live within the surface mixed layer, you be moved around by these turbulence elements. Okay, and then we have something called the mixed layer, the surface mixed layer depth. Okay, it's 100 meters. In some regions can be much deeper. The surface mixed layer. Mesoscale eddies. Okay, so its diameter is 100 kilometers. Okay, so you can be also trapped within a mesoscale eddy. Ocean basins are the largest sizes that we have, several thousand kilometers. Okay, so these are the natural length scales, and then the next thing that we do is we look at the time scales, and just thinking about different time scales that exist. Okay, different time scales, and in terms of just starting in, well, thinking about weather variations that we have. Okay, so this is now from a moment not about the ocean. It's about, just think about the variations that we are experiencing in terms of the weather. So there are day and night changes. That's the day and night cycle. It's the 24-hour period. We have synoptic weather systems and storm passing through an area, 2 to 10 days. And we have seasonal changes. Okay, it's a 1-year period, the change between summer and winter. Okay, and over in the ocean you have similar, you have the same scales, but okay. So now the next thing is something that we call climate variability. Okay, it's the inter-annual climate variability, changes that we have from 1 year to the next. Okay? There's also climate variability on very, very long time scales, on geological time scales of millions of years, but we are not talking about these very long time scales here in this topic. Indeed, we also have a climate change, the human-induced climate change, which is also on relatively short time scales. So it's actually on a time scale which interferes with the time scales of El Nino events. Okay, it's relatively short. We're only talking about decades here. So now on the next slide, we actually try to bring the biological timescales into context with physical timescales. So what's shown here is now on the left axis, the y-axis shows you a marine species which are sorted according to the lifespan, okay, the number of reproductive years, the body size, the swimming speed, and the energy reserves. That's all the same. They're all increasing as you move up. So you start with bacteria, the smallest marine creatures, and phytoplankton, jellyfish, opods, krill, salmon, anchovy, sardine, and tuna. And then the blue bars in this diagram show you the range of timescales that you have for that species. Yeah, for example, bacteria, a lifetimes between hours and weeks, and that's the blue bar there. Okay, and you can see as you move up what on the along the y-axis, that the time scale increases. Okay. So, for example, tuna, you have a lifespans exceeding 10 years at the top. Okay. Sardines, similar, very, very long-living species, but anchovy, and that should be noted here, has a shorter time scale. Okay? So now, at the very top, it actually indicates the time scale of physical events, like seasonal cycles are included there. Yeah, seasonal cycles. And then you have something called ENSO events. Okay, an ENSO event is an El Nino event. And if there's an overlap here, it actually can tells you that an El Nino event can have an impact on a species like anchovy, can be negatively impacted by an ENSO event. Okay. The long-lived species, there's a PDO there. What is PDO? And this is what we're talking about. There are events that happen in nature that can have a detrimental impact on the abundance of certain type of marine species. Okay, so let's start.